Hi, this is Sean Kim, and we're going to write tic-tac-toe in JavaScript. So let's get started. All right, we're going to use Yeoman to create our web app. Take the defaults. Okay, we're going to install underscore. Okay, we need to modify the grunt file. By default, when we modify JavaScript, it runs JS hint, but instead we want it to run the test. Okay, and we need to update the test index.html file, so this way it knows about the underscore. And we also need to tell it about where the source file is located, and that's under scripts main. Okay, so scripts main, in the test directory you notice that scripts is not doesn't exist, but it exists in the apps directory, so it'll look in there. Alright, I think we're ready. So I'm going to run grunt watch. Okay, set up my window. Okay, make sure everything is working. I save the file and it triggers off the test. Great. Alright, so let's create our tests. So for position, new, it creates a board and turn. Okay, so let's create some abbreviations. NP for new position, and dash for 9 dashes, 1, 2, 3, 1, 2, 3, 1, 2, 3, and TA for underscore to array with a left cursor movement. Okay, that should be good for now. So it's a new position. So we expect the position board to be just empty spaces, and the position turn to be X. Okay. All right, we have these warnings. First one, position is not defined. So it doesn't know about some of these global variables, so let's tell it about it. So I'm declaring expect position and underscore. Okay, that should take care of that. And the error is that it can't find the variable position because we haven't created anything. So, okay, let's go to the app scripts main directory, get rid of that, and create a function called position, taking no arguments. And let's just start with a failing test. So now we should get a different error. All right, so expected undefined to equal to a deep equal array. We're using deep equal over here instead of a regular equal because we want to compare the components. And JavaScript is not good about comparing objects, so you need to do it with a deep equal. Okay, so let's start with the board. Okay, so empty, and the turn is going to be X. Okay, so we have some warnings and errors. Okay, so it says missing use strict. Okay, so let's do that. Use strict, and it's also complaining about the underscore. So let's just declare that. So global underscore. Right. So we have a passing test. All right. So the next item is still under new. It's I wanted to take it takes 2 arguments. So let's do the position again, and this time it'd be O's turn, and we'll just put an X right here. So position board, we expect it to equal the board with an X in front. Got a semicolon there. And the turn should be O now. Okay, this should fail. Okay, so board in turn and board defaulting to our previous values. Turn defaulting to X. Okay, 2 passes, great. Okay, now our first method. It's going to be move. It updates the board and turn. So we expect a new position. We make a move, 3, and that should equal a new position with okay, so 3. So 0, 1, 2, 3. Put an X right there. Okay, so this should fail because the function doesn't exist. All right, so P for position. Okay, so position prototype. So now all instances will have move, and that's a function that takes in an index, and let's just keep it like this so we can have a failing test. All right. Okay, it's failing, and let's start this off by this will return a new position. So we pass in the board, so this board, and the turn is this turn. If it is an X, we're gonna pass it an O, otherwise an X. Okay, so we switch turns. We also have to update the board position, so the index is going to be the current turn. Okay, and we just return it, return position. Okay, so this should pass. All right, pass. Next is possible moves. Okay, and that's going, it lists indices of empty squares. Okay, so let's start with a new position. We make a move 3 and move 4. So we expect the possible moves to be 0, 1, 2, 5, 6, 7, 8. Okay. Forgot the 7. Okay. And this should fail because the function doesn't exist. So see, possible move doesn't take any arguments, and let's just return an empty list. Okay. Oh, it says 0. It says 0 passing, which means that we made a syntax error. And let's see what the error is. Oh, I put parentheses instead of square bracket. Oh, I just forgot the square bracket. So let's see if this passes now. Okay, great. So, oh, the other thing that we forgot to do, it says expected object, and move returned the object, but I forgot to call possible moves on this. Okay. All right. So now we're not getting the value we expect, which is what we expected. Okay, so let's think about this. So one way to do this is start off with the, we're going to use a filter. So underscore filter, and starting off with the a range starting from 0 through up to 9. So it doesn't include 9. So it goes from 0 to 8. And we're going to filter out any indexes where, see index, we're going to filter it out. Well, we're going to keep the ones where the board index is, is dash, which is an empty space. And when we're inside of the filter parameter, our third parameter, and it's this. All right. We pass in this because we're using this over here inside of the function, and we want to make sure that this is the same as this that was passed into this function, the outer function. Otherwise, we lose what this is. Okay, so for passing, great. Next is, okay, so we have possible moves. Is win for. Okay, it finds no win. Okay, so that would be a new position, and we say is win for X, and that should not be a win for X, so it should not be okay. Okay, so let's set that up. And that takes in a turn, and we'll just say it's false. Okay, it passes. Okay, we're just using this as a sanity check, so instead of starting off with a failing test, we'll just make it pass. Okay, so this is the important one. So finds a win for X on first row. Okay, so we start off with a new position, actually with 3 X's. Okay, so this is the first row. All right, and we say is win for X, and that should be okay. Actually, we have some warnings here, so let's get rid of these warnings. It says expected an assignment or function call and instead saw an expression. So there's actually a JS hint option which allows expressions, lone expressions. True. Okay. So now those errors went away. Well, warnings went away. Okay, so we still have expected false to be truthy. Okay. Okay, so all right, so let's think about testing the. Okay, so it's going to be for every one of these. Okay, it's a range that goes from 0 to 3, but not including 3. And the test that we're going to use is, let's see, actually, we'll just call we'll create a function here like this. Okay, and match is going to be it takes an index and position board index. We compare that with the turn. Okay, so if it matches the turn. The reason why I created the position variable holding this is because this is special inside of a function, and it starts changing its meaning unless I do something. So instead, I'll just use another variable position, so this way I don't have to worry about losing what this is. Okay, so let's see if this should pass. Let's see. Oh, it didn't. Okay, so let's see. So expect an assignment. Oh, I forgot to say return. Okay. Okay, it passed. Let's do the same thing, except this time on the second row. So all right. So the logic is going to be the same, except that we're going to try out the 3 different rows. So I'm going to say sum. So it's going to be one of these. So sum. Okay. We're going to have an offset of the first row is going to starts at 0, second row 3, and the third row on 6. Okay, so the function, and we'll call this offset. Okay, so I'm just going to take this, put it back here, and okay. So I'm going to do this by the offset. So the first one goes from 0 to 3, and the next one is going to go from 3 to 6, and so forth. Okay, so this should handle testing each of the rows. Okay, and passed. All right, so next, let's try, well, let's just change things around and turn it to O's. And we'll do the second column. Actually, column, so it'll look like this. Is a win for O. Okay, it should fail. All right. All right, so if you want to do the column, it's the same logic. Sum, and the offset we're going to do 0, 1, 2. Okay, and we're going to check the range. Okay, so it starts off from the offset, and it's going to go down until the edge. The edge is 9 in steps of 3. So if we add 3, it goes down to the next row. Okay, and we'll run match. Oh, forgot parentheses here. Okay. All right, passed. All right. Okay, so now we need to do the. Actually, let's just copy this. So it finds a win for O on major diagonal. Okay, so the major diagonal looks like an O here and an O there. Okay. All right. So the major diagonal looks like this direction. The minor diagonal is going to be the other direction. Okay, so let's see. This time there's only one of them, so we don't need to do a sum. We can just do every, and we can give it the coordinates. So that would be 0, 4, and 8. Okay, and we're gonna run that against match. Okay, so that should pass. Okay, 9 passing, and the minor diagonal. Minor diagonal. Okay, let's do the minor diagonal. Okay, so the minor diagonal starts on 2, 4, and 6. Okay, this should pass, and we have 10 passing tests. All right, so we're done with checking for a win. The next thing is Minimax. So, okay, it calculates a win for X. So it expects Minimax to be 100. So if we have a position with a winning position for X, that should be 100. Okay, so let's start that off. All right, we'll just return something bogus just to get a failing test. All right, so this is the this is what the error looks like. The plus and minus signs here is just to show what's expected and what's actual, and this can get a little confusing if I happen to have negative numbers, which I will have in the next test. So so that was a little bit tricky. Okay, so let's think about what this would look like. So Minimax. So okay, so if the if this is a win for X, then we want to return 100. Pretty simple. It should pass. Oops, need to do all three. Okay. Okay, so if O wins, then we want it to be negative 100. Okay. Okay, passes. It calculates a draw. So if I have a position called Minimax on it, that should be 0. So okay, so the position is going to look like XOX, XOX, and OXO. So this is a complete draw and nobody wins. Okay. All right. So okay, so that's good. So if actually it'd be good to have variable p moves is possible moves. So if p moves length is 0, then return 0. All right, passed. Okay, so now we're going to do some calculation here. Take this. Actually, I'm going to take both these and bring them right here, but the second one I'm going to put a skip, so that we can just focus in on this one. Actually, see, in one move. So we're going to take this one away, and that should be 99. For this one, it's also going to be one move. Let's put it in a different spot. So that should be, actually, it doesn't matter which spot it was. Okay, so it'd be negative 99. All right, so let's, okay. Okay, so let's make that pass. So, okay, so what we want to do is, we want to take the possible moves. Actually, we already have it as p moves, and we want to convert all those possible moves into its minimax correlated value. So we can do that using map. Take the p moves and run it through this function. Okay, you'll end up with an index, and so you can just say this dot minimax. No. Yes, minimax. Okay, actually, yeah, you need to make the move first, and then call minimax on it. Don't forget to say return. Okay. all right, and close this. Okay, but once you have the list of minimax values, then you just want to find the maximum. So we'll just use max here, and put, okay, close that up. Okay, I have oh. All right. So I'm still getting a failing. Okay. It says undefined is not a function evaluating. Okay, what could this be? Oh, that's because I forgot to pass in this. Because it loses the meaning of this once you wrap it in another function. Okay, so it says here that this minus can throw you off, so ignore this minus and the plus. So it was expecting 99 but got 100. So I need to account for the depth. So depth, okay, is equal to depth and defaulting to 0. So it starts off as 0. And we're going to subtract the depth and add the depth for this one. And when we call Minimax on its children, we're going to make sure that the depth is added by 1. Okay, so this should pass. Okay, passed. Okay, so now we can work on the second one. Okay, so we have a failing test, and the reason is because when it's O's turn, we want it to be min. So I'm going to rewrite this. So let's see. If you rewrite it like actually, yeah, okay. This gives us the same warning, same error message. Okay, so now I can put a test here. So this turn, if it's x, then we're going to do the max. Otherwise, we're going to do the min. Okay. Huh. Oh. Okay. We have a. Oh. The reason why we're getting different values is because we have to tell the test that it's O's turn. Okay, everything passes. So the last thing we need is best move. Okay, so it finds the best move for X. So let's start off with a new position, best move to be 0. All right, so let's start off with the best move. Okay, so we have an empty spot here, so the best move for that should be at the 0 index. Okay, so best move doesn't exist, so let's just okay, and okay, just going to return 9, which is a bogus number. All right, great. So it was expecting 0 but got 9. That's not a negative 9. All right. All right, so let's make this real. So let's think about this. So we want the max of possible moves. And using this criteria, make the move and find the minimax. Okay, and we need to pass in this, so this inside the function still retains the current context. Okay, this looks good. Oh, I have a warning here. Oh, that's because possible moves should be a function, and it should be based off of this. Okay. So, all right. Oh, before we go on, there is one more thing that I forgot. Okay, so in the Minimax, it calculates the initial position. So we have a new position, and we call Minimax on it, and we expect the value to be 0 because no one can force a win. Okay, so when I run this, you'll notice that the test seems like it stalls, and that's because it takes about 20 seconds for it to calculate the minimax, and because it's not doing a very good job of caching. Still taking a long time. Okay, so we need to add some caching in there so it'll come back really quick. Otherwise, it would be a very, very slow game. All right, so let's set up the caching. So position is now going to have cache. Okay, so cache is an attribute of the class position, not a particular instance. So this way, any position can have access to this cache. All right. Actually, this belongs. Let's put this over here. Okay. So for the minimax, let's see if position cache of this board exists, then we'll just return it. Return position cache this board. Okay, and if it doesn't exist, we're going to go through all of this. Instead of returning, we're going to set the value. Okay, and then return the value. But in between, we're going to set the cache. So that is position cache the board is equal to value. So we're going to store it. So now when we run the test, it should be a lot faster. Okay, that was a lot faster. Okay, so we're done with the engine. So I could turn this off, and we can start working on the user interface. See from the grunt serve. All right, so we'll put this to the side and we put this to the side, so we have it side by side. Okay, first thing we want to do is, okay, so let's get to it. So app index. All right. So let's get rid of all this text that's down here. Okay. All right. So okay. All right, and we'll get rid of this middle text. Okay. So let's create a div called grid. ID is equal to grid. All right, and I'm going to split this up so that I'm going to create a, going to load up the app style sheet. So let's create, actually it's an ID, so hash grid. All right, so the okay, so for the grid, let's see, width is 300 pixels, height is 300 pixels. Okay, and border 1 pixel solid black. Okay, so that would set up the grid. Okay, so that looks okay. Let's change the margin to be auto, so it would be centered. Okay, and we're going to insert, okay, I think this is enough of the, actually for index HTML we need to also include underscore. See, okay, now let's go to the JavaScript file. So that's under app scripts. Okay, all right, so let's put in see, times. Okay, 9 times. See, and we're going to look for grid, and we're going to append div. The ID is going to be sq plus the index, end quote, and div. Okay. Okay, you won't be able to see it probably, so oh, the class, I gotta set the class. So that class is going to be square. So width is going to be 100, height 100, border 1 pixel solid black, and the background color is white. Okay, okay, almost. We need to actually, okay, so if I also need to say float left. Okay, this isn't gonna quite fit because when the grid is being generated, it has a 1 pixel border which takes up 1 pixel. So 100, 100, so 300 is not going to fit in here. It's actually 298. So I need to add, because of the border, I need to add 2 to the width and height for the grid. And so then it would fit. Okay. So now what I want to do is when you click on it, something will happen. Let's see. Let me create a piece. Actually, let's put a okay, an action on the square. So when you click on it, it'll run this function. All right. Okay, so it's going to see. Let's add the piece. So we're going to add, let's see, the class is going to be a piece. And I think okay, and then the contents of that will be position turn. We haven't specified a position yet, so we'll just say variable position is equal to new position. So we create a position, and okay, and then we need to close it. All right. So let's see. Okay, so let's see if this looks okay. All right, so I just saved, and if I click on it, we see the X, and if I click on it, okay. So that works. All right, so let's set up the piece. Let's increase the font size. So in here, let's call the inspector and see, where would it be? Body, the containers right here. There's the Jumbotron, grid. All right. Actually, inside we have the piece. All right. So for the piece, font size 100 pixels. Okay. It's interesting that it went down. Yeah, so let's make it 100 pixels. Top is 0. Float, not float. Position absolute. Okay, so we'll make the position absolute. I think 100 pixels seems okay. We can increase it. Just move it down a little so we can see what it looks like. Top. Interesting. All right. It's not using this top. Okay. So font size. Okay, so let's use 100. Okay, so let's 100 pixels. And what else did we do to it? Position absolute. Okay, start off with this. Actually, I forgot to close this up. Okay, so what else do we need to do here? Okay, so let's see what happens. So the X is put in a really weird position here. Okay. See what happens if I change the height. Okay. It ignores it. Yeah. See what it looks like. Border 1 pixel, solid red. Okay, and height has no effect. Okay, so we can work with this. All right. So when you click, let's set the, let's animate this. So okay. So square. Actually, let's just get the piece. So the piece is find piece. All right, so that should be the piece, and we'll animate it. So piece.animate. Okay, and so we need to figure out what we need to put in here. So we can start with the font size. So font size, actually this should be quoted. Okay, the font size is going to be, let's put 100. Okay, and okay, actually let's just see what happens. Oh, there's problems here. Oh, not semicolon, comma. Actually, let's see what the errors are. Unexpected 1. Oh, okay. Okay, a little bit better. Let's see if this comes back. Okay, good, great. All right, so if I click here, the 1 appears. Okay. Interesting. All right. So let me get the square. So the square, actually we have it right here, so I just make a copy of it and just call it square. And then we can just refer to the square. Okay, so we have the square and then we have the piece. So animate. Actually, what we can do first, oh, actually I forgot the semicolon, is for the piece, let's set the initial font size to be 0. Okay, and well, let's just see what happens now. Okay, reloaded. Okay, so it'll zoom in like that, but we have to adjust the height because the height is wrong. Okay. Okay, so initially let's set the top to be just 0. You can make it all 0. All right, and the resulting top position is going to be based on the parent, so it's going to be square. I think it's position, or is it pause? Top. Okay, animate to that position. So let's see. All right. So if I click here, all right. Okay, and let's just add, okay, actually, all right, so let's add 20, 50, okay, so let's see what that looks like. I'll wait until it, okay. Yeah. Okay, let's go find that. It says top is 0 pixels. So there's top. It's supposed to have animated it. So the piece. Okay, font size 100. Top is 0 pixels. So it's supposed to. This is probably not coming out right. So let's see if position is actually the right function. So let's get the square. So that would be square 0. Okay, let's call this square. All right, so square dot position. Oh, it's a function dot top. Okay, so that's what I needed to do. So it's not just position, it's position as a function call. Okay, so I'll let this reload. All right, so now let's see. Okay, now that's a little bit too far. Maybe subtract 50. Okay, it's a little bit better. Let's try subtracting a little bit more. Like, actually, let's just do. Okay, 60. So let's see what happens if we. 52 would be about. Okay, so a little bit more. So about 14. So 14 more. So that would be minus 60, 64. So let's see. Oops. Okay, that looks about the right height. Maybe a little bit more, so 66. All right. As for the centering, I think that, see, left is going to be square position as the left, but we're going to add 10 to it. All right, and we'll set the left initially as 0. Okay, so let's see what happens. Okay. Oh, I see what's happening here. Let's see. So these, so this area is actually causing it to block my clicks. So, see, for the piece, I'm going to say, let's just put a border around it first. So 1 pixel solid red. Okay, and I'll just set the height to be 0. Okay, so this way it'll be out of the way. We should still be able to click on it. All right, so that would be for the piece, height is 0. Okay, all right, so let's try this. Okay, that looks fine, and I can still click. All right, actually, it looks like it needs to be moved over to the right a little bit more. So let's put 20 there. Okay. So, okay, I think this is about it for the getting the X there, and then we can start working on it actually playing a game. Okay, a little bit more, so 20, let's see, put 5. Okay, all right, so now I'm gonna make it move. So we have the position, and we're gonna say it's gonna move the index. Okay, and it should trigger off the computer to move. So now we also need to know if the game has ended. Actually, the conditions are, let's see, position is a win for X, or position is a win for O, or possible moves length is 0. Okay. Actually, if it's not, so put that whole thing in a not. Okay. Actually, this seems like should be a function called is end, is game end. Okay, and that would be return is a win for X, or is a win for, it's a good thing for syntax highlighting, win for O, or possible moves length is 0. Okay, so that's game end. All right, so once you have a game end, okay, so you can say and not position game is game end. Okay, so as long as the game is still going on, then position is equal to position dot move best move. Okay, so find the best move and make it. Okay, and when that happens, we want the square to be marked. So this whole thing here should really be turned into a function. So let's call this mark square, and it takes an index. All right, so let's see. So this whole thing right above it, all right, so we're going to say mark square index. All right. Let's see, good. Okay, so this, I want to make sure that the only reference is to index and there's no this involved. Okay, so this looks pretty good. All right, so let's see. All right, and then we'll say, actually, let's get the var best is equal to position dot best move, and then we'll just say best. Okay, so mark square. Best. Okay. All right, so let's see. Gonna make a move. Interesting. The computer made a move, but okay, best. Let's see what went wrong here. Let's see. Position turn. Oh, I see why. Because we marked the square after it's made the move. It should do it right here. Okay, so that was a problem. All right, so I'm going to wait until it reloads. All right, so if I click, and it does it immediately. Interesting. Oh, I won. How could this be? Let's try this again. Okay, so it made a move over there. It made a move there. Huh. Best move. I don't know why this is happening. Let's take a look at the test, see if we forgot something. So, okay. Oh yes, we did forget something. Best move finds the best move for X, but we forgot to say find the best move for O. Okay, so in this case, let's, okay, best move should equal 2. Okay, and let's bring this back up here and run grunt watch. Okay, so save, should see grunt watch, fatal error. Oh, it's already used because of the server. The server's running. So let me just kill the server. And all right, so let's try this again. So I'll save. I'll actually watch now. Okay, so it's watching. I'll save. Okay, 18 passing. Oh, that's because it's O's turn. All right. So let's fix up the code. All right. So best move, here it is. So this is only using max. So we should say this turn, if that's an X, then we use max. Otherwise, we use min. Okay, and this should pass. Okay, so let's kill this and go back and start the server again. Okay, and let's bring this to the side. Okay. All right, so now see if it plays much better now. And the game is over. Okay, reload to start a new game. So I'm just gonna, let me try to see if, oh, actually, I don't even have to try to lose. I lost. There it is. Okay, so, and we can add some more features to this, but we have the tic-tac-toe in JavaScript.